Hello everyone, welcome to Qual2K tutorials. Today we are going to learn about the inputs in the sheet number 4, which called rich. In this sheet we need to insert a lot of values and parameters related to the river characteristic in terms of locations and elevations, downstream longitude and latitude, and also if we have where we need to insert it as well, and we need to insert as well one of these three options: where equation or writing curve equation or Manning formula to solve the hydraulic characteristic including flow velocity and flow depth. Later on, we are going to insert some or several parameters here. If we have those values, we can just insert it directly. If we don't have it, there are some equations that will be used by Qual2K itself. So as I mentioned before that, here in Qual2K, we need to key in the values in the cells with blue colors only. Therefore, these cells with green colors, we don't need to insert anything because these will be the outputs from Qual2K itself. Before we start, I would like to explain something related to this sheet. Let's go to the manual, and you can see here in the manual section number 3, segmentation and hydraulics. If we can read the first paragraph, the model represents a river as a series of reaches. These represent stretch of river that have constant hydraulic characteristics, such as slope, bottom width, etc. So, what does that mean? This means that if we have a river with a length of 157 kilometer, we need to divide it into reaches. Each reach has a length. So how can we divide our river into reach? It's mentioned here in the manual that the reach supposed to have same bed slope, same bottom width, same soil type, maybe same top width. So let's have a look here. I will explain it more. Let's say this is our river. And for example, let's see now, for example, from the upstream point to this location, in this length of the river has the same bed slope, same bottom width, same top width, and maybe other characteristics is the same for this length. So this one we will call it reach number 1. Same thing goes to reach number 2. For example, let's say this length of the river has the same characteristics. So we'll call it reach number 2. Then same go to reach number 3, then 4, then maybe at the end is 5. So in this case, this river consists of 5 reaches. The reach numbering for a single river start from the upstream. So this is upstream, and this is the downstream. In case we have a river with tributaries, so let's say this is the main stream, and this is the first tributary, and this is the second tributary. How can we number our reaches? Numbering the reach in this case will be like this. So let's see, this is the upstream of the main stem, and this is the upstream for the first tributary, and this is the upstream for the second tributary. So the numbering will be like this. So this is reach number 1, 2, 3, and 4 to this point. So let me give it a number: 1, 2, 3, 4. We will not continue now to the downstream. We will go back to the upstream of the first tributary. So this is number 4. This one will be number 5, then number 6, then number 7, and this is number 8. Then we will go to the downstream of the main stem. This is number 9. Then let's say to this point is number 10. Same thing, we will do it here with this tributary number 2. We are not going to continue to the downstream of the main stem. Instead, we will go back to the upstream of the second tributary. So this one will be number 11. This is number 12. And here 13. Then 14. Then after that, let's see here 15. Then finally, last ridge is 16. So now you can see the difference between these two cases. So this is the first case, which is one single river with no tributaries, which we are going to do in today's tutorial. While this is as the second case with a river with two tributaries, and here you can see how did we arrange the numbering of the ridges. Actually, you can find more explanation about ridge numbering in the manual. It's mentioned here. So this is a single river and how we arrange or number our ridges. While here you can see a river with tributaries, and in this case we have three tributaries. This tributary number 1, tributary number 2, and this is tributary number 3. So the same thing that I explained is explained here with more details. You can see 1, 2, 3, 4, 5, then 6, 7, 8, and after that we'll go to this, the sub tributary, the 9, 10, 11, 12, then so on. So if you are going to simulate a river with tributaries, you have to be very careful with these values. So for example now, let me show you something in Qual2K software itself. For example, let's see if we have more than one headwater. Let's see if we have three headwaters, as I mentioned in the previous tutorial. So this one will see this 3. We'll keep this number as 3 headwaters, as in this example. So we have one main stem and 2 tributaries. That means we have 3 headwaters at the upstream of each river. Then here we can insert the mainstream headwater ridge number is number 1, which is this one. This is the headwater ridge number for the main stem. So if we go downward to here, if we scroll down, so we can see headwater number 1 for tributary number 1. So we need to define the ridge number here. We need to insert a value here. So this value in our case will be 5, will be ridge number 5, this one. Then after that, when we insert the second or the third headwater in tributary number 2, so this is the tributary number 2, we need to insert the ridge number here. So this value in the case that I'm explaining now will be number 11. So here we will insert number 11, and here we'll insert ridge number 5. So now I'll just put this as 1 because today we are going to simulate a single river with 3 tributaries. And here I delete this value, and also I'll delete this value, and I'll keep the original values. Here we have only one headwater, and the ridge number for the headwater for the main stream is 1. So now let's go back to the ridge sheet. Then we will keep these two values or to these parameters to the end. I will explain it at the end of the tutorials. Okay guys, now let's go to row number 9 and column A and B. These two cells containing the label for the upstream and downstream for each and every segment. So you can see here this is the mainstream headwater, And after that we have several labeling here. We have several dams along the river. Just let me show you this sketch. And you can see here, this is the upstream and this is the downstream of the river. And we have several dams along the river. It's around 14 dams. So from the headwater, the length or the distance from the headwater to the first dam is around 26 kilometers. So if we go back here to Qual2K, you can see this is the main stream and this is the first dam. And if we get the difference between the headwater and the dam location, just let me calculate it here and see uh, this value minus um, this value, then equal. So you can see it's around 25.938 kilometers. As I told you before, the total length of Fox River is around 157.44 kilometers, as you can see here. So we put the total length of the river at the beginning of the river, I mean at the upstream location, and we put 0 at the downstream of the river. So let me show you Fox River in the map. We got a better idea. So this is Fox River. You can see here this is Fox River, and if we go up to the upstream, upstream is located here. Okay, so the upstream located somewhere here behind the lake, and the downstream location, the downstream point of this river is located here. You can see uh, it's after the Dayton Dam. So if we go back to Qual2K, you can see that the last segment was after the Dayton Dam. So this is the Dayton Dam, and we still have around 9 kilometers to the other river. So this is the Dayton Dam, and this is the other river. So this distance from this location here, from the intersection between the two rivers to the Dayton Dam, is around 9 kilometers. Okay, now let's see how did we insert uh, the other values. So now you know how to insert the labeling, and now let's move to the first input after the labeling. So as I told you, the labeling is optional. You can insert it and or you can keep it empty. But here we'll start with the location of the upstream and downstream of each segment, and the user must insert or key in all these parameters. So how can we key in these values? Just let me show you this Excel file. So as I told you before that the length of the river equal 157.442 kilometer. So this value, the length of the river, we put it as the first value. So now this value, the second value, the downstream, this is the downstream of the first segment. So this distance, let me calculate this distance, the length of this segment, and it's equal this value minus this value. So this distance of the river has the same geometry characteristics such as bed slope, bottom width, top width, soil type, and so on. So we consider it as a segment. So if I extend this for other segment, so you can see here this is the second segment, the length around 4.184 kilometers. So this segment with this length also has the same geometry parameters such as bed slope, bottom width, top width, soil type, side slopes, and so on. So now, how did we calculate the element numbers? You have to know that it have to be equal to or more than 1. So in this example, the element the element length uh, is assumed to be 0.25 kilometers. So that means around 250 meters. You can choose the element length based on your interest. In this example, we choose it to be around 0.25 kilometers, which equals to 250 meters. So now let's see how did we get the element number here. These values 6, 17, 11, 2, 17, and so on. So as I mentioned before, and here is the segment or ridge length in kilometer. And here, if we need to quote the element number, we will just use this equation. We'll say the segment or ridge length divided by the element length, which is 0.25 kilometers. So you can see here it's equal to 6 elements. If I extend this to others to other segments, you can see and compare these values with these values, and you can see it's almost the same. And here you can see some values equal to 1. So in this case, you can find out that the segment length is around 0.15, which is less than the element length, and here it's automatically become 1. My recommendation here to choose the element length, you can choose it as the lowest value in the ridge length. So for example here, you can choose the element length equal 0.15 kilometers. So it's around 150 meters. So in this case, if I choose the element, let's see, if I choose the element length equal to 0.15 kilometers, then the element number will be changed based on this equation. Element number equal to the ridge length or segment length divided by the new length of the element. Then you can see here it's increased to 10. So I extend this for the others, for the other segments, and you can see here all element numbers were changed to a higher values. So simply, if I'm going to use the element length is equal to 0.15 kilometer, I'll just copy all of these new values I get, and I'll just paste it in Qual2K in this column. Let's move to the elevation. You can see here we have the elevation of the upstream and the elevation of the downstream for each and every segment. And you have to have these parameters, and you must insert it in Qual2K. So you can see here all upstream and downstream elevation for each segment was inserted accordingly. And now the user must insert the downstream longitude and latitude for each and every segment. And you have to insert it in degree, minute, and second. So for example, the first ridge, which is located at the headwater, the mainstream headwater, you can see here that the longitude and latitude was inserted in terms of degree, minutes, and seconds. Now let's move to choose one of these three models to solve the hydraulic parameters, including flow velocity and water depth. So here is the first option, which is weir equations, second is the rating curves equations, and finally we have the Manning formula. And I have already explained these three options in the previous tutorial when I explain the second sheet, which is headwater. In this example for Fox River, we choose we choose rating curves to solve the hydraulic parameters, including flow velocity and water depth. So here we can see we inserted the velocity coefficient and exponent, as well as we inserted the depth coefficient and exponent. As I mentioned here that we have several dams along the river. We have about 14 dams. You can see that in this sketch. And here we define all the dams as a sharp crested weir. So here you can see from this sketch the first dam located around 26 kilometers from the headwater, which is Algonquin Dam. So here, after this distance, after 26 kilometers, we inserted the first dam, and we define it as a sharp crested weir. And we have another option here. If we have boat crested dam, we can just select boat crested dam. So for now, I'll just use sharp crested dam. Then after that, I need to insert its height and its width, and finally we need to insert these two coefficient ADM and BDM, which can be calculated experimentally for each and every dam. But here you can see we have ADM around 1.25 and BDM around 0.8, which was the default values here in Qual2K. After we define these four parameters, we need also to go to the Manning formula and define the bottom width for each weir. So you can see here we define the bottom width only at the location of the dams. So now let's move to the end. We still have a few parameters here. We need to insert all of them. If we have these values, we can just insert it. If we don't have these values, Qual2K will use built-in equations that can be used to solve those parameters, such as this value prescribed separation, which I explained it earlier before when I explained the parameters that we need to insert in headwater. So this value, you can refer back to the previous tutorial and you can see which equations that can we use to calculate this parameter. And also if you have these parameters, such as in this example we have the bottom algae coverage 50%, and it's a constant value along the river. And also we have bottom SOD coverage 50% as well. So these values we have it, we just inserted here. The other values Qual2K will calculate it automatically if the user didn't insert it. But it's recommended that if you have the values and parameter, you just put it here. I think this is the all inputs that you need to know about it in this sheet. But we still have these two parameters. I'll just see it too fast. So you can see the reach for Dale plot. And actually here in Qual2K, we need to choose one reach or one segment, and we need to specify which element in this reach. For example, here you can see we choose the reach number of 26, which is this one here, and we choose element number 1. So let's see, here we have 10 elements. That means we choose the first element of the segment number 26 for Dale plot. Let me show you what is the Dale plot here in the results, and you can see here. For example, let's have a look in the for example, yes, here you can see a lot of figures and results. I'll just choose, for example, dissolved oxygen, and you can see here the dissolved oxygen was solved in bridge number 26, element number 1, and it was solved for 24 hours. So you can see here, this is 0, and here we have 24 hours. So you can see here how the dissolved oxygen change along the 24 hours. I can see here it's decreased, and after that it increased. Maybe here the increasement was due to more pollutant into the water during some hours during that day. And finally, I'll just want to mention one important point here, which is related to the river with tributaries. So as I told you before that, rivers with tributaries, we need to be very careful with the rich numbering first, and after that, we need to be very careful when we insert the data here.